dimensional cone by a flat plane, and by intersecting a cone with a flat plane, we get one of these. You either get a circle, a parabola, an ellipse, or a hyperbola. And this unit, we're going to go through all of these. We're already masters on the parabola, so obviously we're not going to do too much with that, but we are going to get into the nitty-gritty of circles, ellipses, and hyperbolas. And today we start with circles, and circles is the easiest one because you guys have seen circles a lot. You should have seen it a lot in geometry, and we're just sort of going to pick up from there. I mean, it's not that serious. Don't worry. Don't be scared. All right. So definition. Okay. So by definition, circles are a set of points equidistant from a given point that we call the center. And if you guys remember from geometry, we have our center point, and then we have a whole bunch of points around that center point. And what this means is from the center to any point on that rim of the circle is an equidistance, meaning it's the same distance from that center. So that means all these segments are congruent. Does anybody remember what that segment is called from the center to the rim? Justin? Radius. And if you remember from geometry, all the radii are congruent. All right, so now what we're going to do is we're going to talk about the equation of a circle in standard form. So the equation of a circle in standard form is represented by the quantity of x minus h squared plus the quantity of y minus k squared equals the radius squared. And in like every other equation that we have, all these variables mean something. So the point h comma k is going to represent the coordinates for the center of the circle. R is going to represent the radius. Anybody want to take a guess what x and y represent? Same thing it represents on a line, same things it represents on a parabola. Pranav? Perfect. X and Y represent all the different combinations of points that exist on the circle. So we're going to say X comma Y is going to be all points that are on the circle. So now we're going to talk about a circle versus a parabola. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. And a parabola is either y equals the quantity of x minus h squared plus k, or x equals y minus k squared plus h. Do we agree? Those are the equations that we know, or the formulas, I should say, we know. Okay. So as we keep building the different conics, so we know parabola, we know circle, we're going to get to ellipse and hyperbola. But what's going to happen is I'm not going to give you something in the format. So I won't give you a circle in standard form. I won't give you a parabola in vertex form. I'll give you some form of it not in the right form. And then I'm going to ask you, what type of conic is this? And how are we going to know without wasting the whole period by putting everything in its right format? Well, here the circle has both x and y squared, right? Circle, if we were to FOIL this out, wouldn't it be x squared and y squared? Now, regardless of either parabola, whether it's a vertical parabola or a horizontal parabola, only one of them will be squared. So in a vertical parabola, only the x would be squared. In a horizontal parabola, only the y would be squared. So if both x is squared and y is squared, as of right now, based on our knowledge, what does it have to be, a circle or a parabola? A circle. If only one of them is squared, then it's immediately a parabola. And like I said, we're going to keep building this and we'll figure out how to distinguish as we go on. Okay, so let's do some sample problems. So I want us to write an equation of a circle in standard form with a center 0, 3 and a radius of 7. Okay, so the standard form of an equation of a circle is going to be the quantity of x minus h squared plus the quantity of y minus k squared equals the radius squared. And now in order for this equation to make sense, we need a value for h, we need a value for k, and we need a value for r squared. So let's go and plug in. Well, they said the center is 0, 3. So remember, the center is hk and the radius is r. So now all I have to do is plug right in. We have everything we need. So this is going to be x minus 0 squared plus y minus 3 squared equals 7 squared. Do I need that x minus 0? No. We're going to write this as x squared plus the quantity of y minus 3 squared equals 49. And so this is the equation of the circle in standard form. You can include the 0. I would be okay with that. All right, next one. So once again, I want us to write an equation of a circle in standard form with a center of -3, 5 and passes through the point 7, -3. All right, so again, I want an equation of a circle in standard form, so I'm going to write that out. The quantity of x minus h squared plus the quantity of y minus k squared equals the radius squared. And in order for this equation to make sense, I need a value for h, for k, and r squared. Well, we know the center is h comma k, so I already have an h and a k. So I'm going to plug that right in to my equation of a circle. So we're going to have x minus, now be very careful, it's minus a negative 3. So we have x minus a negative 3, quantity squared, plus y minus 5, quantity squared, equals the radius squared. So now that double negative makes a positive, so this becomes x plus 3 quantity squared plus y minus 5 quantity squared equals r squared. Is this good enough? No, I still need an r squared. They did not tell me a radius, but they did tell me that it passes through the point 7, negative 3. Does anybody know how I can use the point 7, negative 3 to help me find r squared? Talon? Perfect. Remember, in the equation of a circle, x comma y represents all the points that exist on the circle. So what we're going to do is we're going to plug in 7 for x and negative 3 for y, and then we're going to solve for r squared. So now we're going to have 7 plus 3 quantity squared plus negative 3 minus 5 quantity squared equals r squared. Well, 7 plus 3 is 10. 10 squared is 100. Negative 3 plus negative 5 is a negative 8. Negative 8 squared is a positive 64. 100 plus 64 is 164 equals r squared. Do I even need to take the square root of both sides? No, because I don't need r. I actually need r squared, so we're done here. So now we can put it all together. X plus 3 quantity squared plus y minus 5 quantity squared equals 164. That is the equation of this circle. Okay, next one. I want us now to find the center and radius, then graph the circle. What's the problem here? I'm giving you a circle that's not in what? Standard form. And so can I identify the center or the radius if it's not in standard form? No. How do I know that this is a circle and not a parabola? Jaspreet? Good. I know this is a circle and not a parabola because both x and y are squared. So now I can't graph or identify the center and the radius looking like this. So I have to manipulate this. I have to put it in standard form. How do you think I'm going to recommend we put this in standard form? Ilya. Completing the square, you got it. So what I'm going to do is I'm going to group my x's together. So we have x squared plus 8x. I'm going to group my y's together, y squared minus 6y equals 0. So now I'm going to complete the square for the x. I'm going to complete the square for the y. Start off with the x. Half of 8 is 4. 4 squared is 16. Now, I don't want the 16 to make cancel each other out on the same side. I actually need a number on this. Why do I need a number on this side? Well, yeah, but also, what is this side going to be? Our radius, right? It's going to help us identify our radius. So normally, since I added 16 on this side, if we were dealing with a parabola, wouldn't I then subtract 16 outside of the parentheses? but I don't want to do that. So to negate the 16 I added here, or to balance it out, I'm going to add 16 on the right side. Because subtracting 16 on the left side or adding 16 on the right side, isn't that the same thing? That's balancing it out. So I'm going to add 16 on both sides. And then I'm going to do the same thing for the y. Half of 6 is 3. 3 squared is 9. So I add 9 to the left. And then I don't want to subtract 9 on the left. What do I want to do? Add 9 to the right. You got it. So now we can finish this up, and it becomes x plus 4 quantity squared, and then y minus 3 quantity squared equals 25. So now I've now put this equation in standard form. Now I can identify the center and the radius. What's the center going to be here? Excellent. Negative 4 comma 3. What's the radius? 5. Perfect. How come it's not negative 5? Good. A radius is the distance from the center to a rim. Can we have a negative distance? No, that's why we're only keeping the positive version of it. So it says find the center and the radius. Got that. Now it says to graph. Well, in order to graph a circle, all you need is a center and a radius. So I'm going to go ahead and I'm going to graph this. And our center point is negative 4, 3. And then from that center point, I'm going to count 5 to the right. I'm going to count 5 to the left. I'm going to count 5 up. And 5 down. And then you connect. It looks something like that. Doesn't look like the best circle, but it's good enough. All right, you guys try this next one, and then we're going to move on. So same directions. X squared plus y squared equals 4x plus 9. So I want you to identify the center. I want you to identify the radius, and then I want you to graph. And I will tell you guys, the radius is not going to be, the radius squared is not going to be a perfect square. So you're going to have to estimate the radical. You'll have to estimate the radical. Yes. The square root of 13, like the estimation of it, I estimated around 3.6. I'm going to go through when we go over it, how to estimate it. All right, guys, who thinks they have an equation in standard form? Hurley. Could we have just done y squared? Perfect. So we have x minus 2 quantity squared plus y squared equals 13. Does anybody need to see me complete the square to show you how we got this? Okay, so now if this is my equation in standard form, the center is going to be 2 comma 0. And now the radius is not 13, guys. The radius squared is 13, which means the radius is square root of 13. So now when it comes to graphing this, I need to estimate the square root of 13. The way you estimate it is you pick the two closest perfect squares. So I'm going to go with the square root of 9 and the square root of 16. Square root of 9 is 3. Square root of 16 is 4. So I'm somewhere between 3 and 4, slightly closer to 4. What did you guys estimate? Yeah, 3.6, 3.7 would work. I like 3.6, which is really going to look around like 3.5, to be honest, when we're sketching this. So now when we go to sketch this, our center is 2, 0. And then what we're going to do is we're going to move about 3.5 in every direction. So we're going 3.6 up, 1, 2, 3, and then 0.6. 3.6 down, 1, 2, 3, and then 0.6. We're going to go 3.6 to the right and 3.6 to the left. And so it looks something like this. All right, so now we are done with circles, but we're not done learning for today. We're going to start ellipses. We will not finish ellipses, but you won't have homework. So that's a win. So you could start a new page. I'm going to say Unit 13, Day 2, ellipses. Yes. So visually speaking, guys, how does an ellipse generally look different than a circle? Like what makes it different from a circle? Yeah. Yeah, so it's not, so you know how for a circle, every direction is the same distance from the center. For an ellipse, it's not. So to the right and the left is the same distance, and top and bottom is the same distance from the center, but one will be longer, one will be shorter. So that creates two different types of ellipses. The first type of ellipse we're going to talk about is a horizontal ellipse. So here's like a little sketch of what a horizontal ellipse could look like. And basically for a horizontal ellipse, it's longer in the x direction and shorter in the y direction. So for a horizontal ellipse, it's longer in the x and shorter in the y. And I'm going to write that out for you. Say longer in the x direction, shorter in the y. So I like to call him short and stout. A horizontal ellipse is short and stout. So if that's the horizontal ellipse, let's bring us to a vertical ellipse. So if a horizontal ellipse is short and stout, a vertical ellipse is tall and skinny. And so for a vertical ellipse, we're going to be longer in the y direction and shorter in the x direction. All right, some vocabulary word here that we're going to learn is minor axis, sometimes called the minor diameter. And basically the minor axis or the minor diameter is the direction the ellipse is short in. Generally represented by 2b. So if the minor axis or the minor diameter is the direction they're short in, what do you think we're going to call the direction we're long in? The major, you got it. So that's the next one. So we're going to say the major axis or major diameter is going to be the direction the ellipse is long in, generally represented by 2a. It's going to be the actual length. So the 2a is the actual length. The major axis is the direction. All right, so some information about an ellipse. If you take any point on an ellipse and measure the distance from that point to two special points called foci or focuses, both versions are used. The sum will always be equal to a constant of 2a. Put a little star. We're going to say the foci lie on the major axis symmetric to the axis, symmetric to the origin, sorry, symmetric to the origin. What does that mean, symmetric to the origin? What does that mean, symmetric to the origin?
They're like the same distance.
Good. It means they're both the same distance from the origin. So from the origin to one focus, if it's 1 unit, then from the origin to the other focus will also be 1 unit. That's what it means, symmetric. It's creating mirror images around the origin. All right, let's keep going. I guess, not sorry, I shouldn't write the origin. That's only if it's centered at 0, 0. We should say to the center, symmetric to the center. All right, I'm going to get a little visual going for you. Okay. So these aren't real coordinates. So I'm not actually counting. I just did it to help it look a little bit more symmetric. But if this point is negative A0, this point is A0, this is 0B, negative, oh, sorry, this should have been 0, negative B. Let's fix that. Should be 0, negative B. The middle point is the center, and then F1 is the first focus, F2 is the second focus. So I'll let you copy that all down. Okay, now, based on what I told you before, it is saying any point on the ellipse to the focus, or to both foci, I should say. So the distance from any point to both foci. So I'm going to draw from 0B to F2. So the distance from 0B to F2 and from 0B to F1. So this is distance 1 and this is distance 2. They're saying if I were to add those two distances together, D1 plus D2, that's going to equal 2A. Okay, so now let's say I want to find the focal length. What is the focal length? The focal length is the length from the focus to a point on there. What we're going to do is we're actually going to use this right triangle that we have here. Oh, sorry, not that. Sorry, the focal length is going to be, sorry, the distance not from F2 to 0B. It's going to be from F2 to the center of the circle. That's the focal length that we're going to call C. This is what we want to find. The distance from the focus to the center is the focal length. Now we're using this yellow triangle, this right triangle, and we're going to derive the formula. So you don't really have to pay attention to this if you don't want to. You could just say, okay, let me just know what the formula I need to memorize is, and you could turn off your brains right now. But if you want to see how it's derived, I'm going to show you. So we know from our center right now, which is the origin 0, 0 to the point 0B, isn't that B units? All right, we're saying from F2 to our center is C units. We don't know what that is. And from F2 to 0B, since D1 plus D is 2A, that means these are each A units long. So what does this mean? I'm going to use the Pythagorean theorem. And so if I use the Pythagorean theorem tells me C squared, which is what I want to find. Or sorry, let's do the Pythagorean theorem is A squared plus B squared equals C squared. So C squared plus B squared equals A squared, right? Leg 1 squared plus leg 2 squared equals the hypotenuse squared. That's the Pythagorean theorem. And A this time is our hypotenuse, not C, because I labeled A as the hypotenuse. So now I want to solve for C. So if I'm going to solve for C, we're going to have C squared is equal to A squared minus B squared. And now to undo a square, we take the square root. So now C is technically equal to plus or minus. But why am I not including the minus part of this? Why am I not including the negative? Lucas. Good. It's a distance, and distance can't be negative. So C will equal the square root of A squared minus B squared. And so to find the length, the focal length, our formula is going to be C equals the square root of A squared minus B squared, where A is associated with the major axis and B is associated with the minor axis. And this is where we're going to stop for today. Next class, we'll do a little bit more with this. 103. Yeah.